Hi everyone, in this video we will be going over scale factor. Our essential question for today is, how is the scale factor used to find unknown dimensions? One more time, how is the scale factor used to find unknown dimensions? So first we're going to talk about a scale drawing, and a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. So this is a map, and then these are kind of like little scale drawings of different buildings. And what you can see is these are obviously not the exact size of those buildings or that map, because those places or those buildings are very large, they're huge. However, scale drawings are used to talk about an object that is real, that is actual, but on a smaller scale that people can relate to. So for instance, in this map, they're saying for every, maybe it's inch or 2 inches, that's 3 kilometers. And that represents 3 kilometers on the map. Whereas on here, maybe they're saying that for every inch of this, maybe this is 1,000 feet or 500 feet. And then those things represent actual objects in a place, but we use scale drawings to either enlarge them or to reduce them. Now, a scale is a ratio between two sets of measurements. So for instance, in this example, there's a photo, and this one is in inches and this one is in feet. So we're talking about something that was small becoming something that is larger. And so that's the ratio, that's the scale. Now the scale factor is the specific ratio used to enlarge or reduce similar figures. So again, the scale is that ratio, and the scale factor is that ratio that you are using. So let's talk about what the scale factor is between these two photographs. Now, when we look at this, you can see that this is 9 inches over here, and we've got over here, this is the same image, and it has the same dimensions. However, this one is 18 feet. So if you think about that, and you were to look at this, you can see that for every inch represents 2 feet. So what we have on here is for 1 inch represents 2 feet. So in the smaller photograph, we've got 9 inches. However, now that we're enlarging it, we're going to make each inch represent 2 feet. So that means we say, okay, 9 times 2, that's going to be 18, and that gives us 18 feet. Whereas this one down here, originally it was 16 inches, now it's going to be 32 feet, so it's much larger. So that's why we're talking about something that is becoming smaller or larger using that specific scale factor. So once again, that scale factor is that ratio that is enlarging or reducing similar figures. Now, one thing that is important to note about this is that the lengths and widths of the photographs of any scale drawing will be proportional to the lengths and widths of the actual photograph. So it doesn't mean they're the exact same, but it means that they are proportional. And what this means is, imagine that you have the ratio of your scale drawing. That is simply 9 over 16. However, we've got an actual drawing ratio, and that's 18 feet over 32 feet. It's kind of hard to compare these, though, when they're in different dimensions or different unit rates. But if we were to put this into inches, we could just times 18 by 12 and 13 by 12, and that turns it into inches. Now again, this isn't showing me that these are the same, that they're proportional. However, if I were to reduce it, I could divide them both by 24, and it becomes 9 inches over 16 inches. So these end up being the exact same. Oh, that's a terrible arrow. So these end up being the exact same. And so what this tells you is that they're proportional, because if you think back to our last set of notes, whenever those fractions are the same, it tells you that that is your scale factor and that is proportional, or they're equivalent. Okay? So here is a practice problem, and try to find the scale factor of these Spider-Man posters. All right, now let's talk about determining actual distance. So we have a map of California over here, and you can always look down here and there's these different scale factors. And this one has a scale of 2 inches that equals 40 miles. So right here, this is very important information, so I'm going to underline this because we want to keep that. Now it says the distance on the map, okay, so not the actual distance, from Los Angeles to Yosemite is 14 inches. So this is the scale drawing. They're saying from down here, I think, where is Los Angeles? Right here, all the way up to here is 14 inches on the map. But we want to figure out what is the actual distance from Los Angeles to Yosemite. Now, the very first step that we want to do is to create a proportion. And this will help us solve that distance from Los Angeles to Yosemite. So we set up our ratios. And first of all, our very, very first one that we've got is at 2 inches over the 40 miles. That's our scale factor. Now we're going to compare it to the actual. So this is our scale so far, and we're going to compare it to the actual things, the map and the real life. So one thing that's important to note is if I have inches here in the numerator, then I also better have inches over here in this numerator for this ratio. And if I have miles in the denominator, then I also need to have miles in the denominator for the actual size. Now, right now we've been given that the distance on the map is 14 inches. So that has to go into the numerator, just like there are inches over here in the numerator on our scale factor. Which means the thing we do not know is how many miles is the actual distance from Los Angeles to Yosemite. So we're looking over here and we're trying to find whatever those X miles are. Now, when you're solving this, remember you're just using that proportion. So you're multiplying the 2 times X and the 40 times 14. Okay, so you end up getting 2X equals, and I don't know what that actually is, so give me 1 second. Equals 560. And then when you divide on both sides, you divide both sides by 2. And then that will give me 280. Okay, so you get 280 miles, so X equals 280. So this is our actual distance from Los Angeles to Yosemite. And all we needed to do was set up a proportion. So whenever you're trying to use scale factor, remember that you're going to be using proportions again. All right, you have a practice problem of your own. This time you have a map of the United States, and it has a scale factor of 3 inches to 300 miles this time. Now, the distance on the map is from San Diego, California to Miami, Florida, and that is 26 inches. You're going to need to create a proportion and then figure out the actual distance from San Diego to Miami. And if you get stuck on this, just re-watch that last problem we did and go through those exact same steps again. All right, similar figures. So this is another type of scale factor, but we're using similar figures. And when you do this, whenever you're working with scale factor, it all comes back to creating proportions. And if you can create proportions, you're going to be fine. Now we've got two triangles here, and they are similar, but if you can see, they're set up differently. Now the way that will help you is try to find, like if you were to turn it, what direction do you need to turn it so that they look the same? Now in this case, I just see that this is a right angle. Okay, so this is a right angle. And then I've also got a right angle over here. Okay, so that means if I was to turn this one, the small one, I could just turn it this direction and it would be the same. Okay, so if I was just to turn this, basically it's like you're turning it that way. Then it ends up being the same figure. And you've got now 3 inches is on the bottom, you've got 4 inches over here, and then 5 inches is across from that right angle. So when you make your proportion, it's important that you understand where those equivalent sides are, because you can't compare 3 inches to 10 inches because they're not in the same location. But you can compare 3 inches to 7.5 inches because they are in the same location. So when you start to build this, you need to create your two ratios again, and we know that we're going to have to find this long side over here. So I'm just going to compare something that I do know. I do know that 3 inches is going to be the same side as the 7.5 inches. So my scale factor, I could just say, is 3 inches to 7.5 inches. And then what I know is I know I am missing this x over here, and that is the same as the 5, so it's similar to the 5. It's not the exact same, but it's similar. So when I think about this, remember the smaller triangle right now is in the numerator. So the next number I need to have needs to come from that smaller triangle, and that's going to be the 5. Now on the bottom, I'm talking about the larger triangle, and that's where the x comes in because I do not know that value. And then from here, you just simply follow those proportion rules of the cross product rule. You get 3 times x, and you get 7.5 times 5. And that is it. And so then you walk through, and 3x equals 37.5. You divide by 3 on both sides, and then you find out that x is 12.5 inches. So then you just follow through those same proportion rules. But you just have to make sure that you line up the smaller triangle and then the larger triangles with each other so that you're setting up the proportion correctly. All right, you've got one more problem to try on your own, but this is a very short set of notes. So once you're done with this problem, you are done. And if you have any questions, please let me know.